Welcome to the morning session of the Saturday of PyCon 2013. We've got a few good talks for you this morning. Up first, we have Gary Bernhardt, who's going to be talking about boundaries. Please make him welcome.
Okay, I just got to this building, so I'm kind of like not in the right headspace. But the title of this talk is Boundaries, as you heard. I am Gary Bernhardt, as you also heard. I look like that on the internet, where I say mean things about Python. And I own a company called Destroy All Software that publishes screencasts. And this talk is a little bit all over the place, much like I am this morning. I have to talk about a lot of different things before I can bring them together. And the first of those things is test doubles, which means mostly things like mocks and stubs. Suppose we want to test a system that has recurring billing, and when a user's credit card fails to be charged, we want to email him and tell him that something is wrong. So we're going to write a test that says it emails late users, and we're eventually going to invoke a class called sweeper, and the sweeper sweeps up all the late users and yells at them. Of course, we need a user to yell at, so we're going to make a Bob. He is going to be a mock object, not a real user, because I want to isolate the sweeper for this test. I want to only execute code inside the sweeper. Bob last paid a month ago, so we need a month ago. I'm going to do it a really nasty way because it fits on a slide. The right way to do this is actually a little bit longer. And then we need a way to get Bob into the sweeper. We're not passing him into the sweeper, so the sweeper has to pull him out from some other object. If this were an integration test, probably we would save Bob to the database, and then the sweeper would pull him out and do whatever it needed, but we can't do that because we're isolating. So instead, I'm going to mock out with mock.patch the user.all method to return the array of Bob. So the sweeper will see Bob as being the contents of the database, even though there's no database there. And then finally, we've not yet written an assertion. We need to somehow ensure that an email is being sent. So I'm going to, once again, use a mock to do that because I can't let it actually send email. So I'm going to use mock's patch decorator once again to mock out the usermailer.billingProblem method, which is the method that sends the email. And at the very end, I can assert that it was called once with Bob as an argument. So this is an isolated unit test. It's isolated because it only executes code in sweeper. It does not execute code in user or in user mailer, just in the sweeper. The production code is pretty straightforward for this. We have a sweeper class, we have a sweep method on it, and I just like using classes as containers for methods. You could make this a global function, it would be fine. We're going to pull all the users out of the database and select only the ones who are active users and have paid more than 1 month ago. Once again, we're going to use the bad definition of a month ago for simplicity. And once we have all those late users, we can iterate over them and send them each an email saying something's wrong. So this is the production code that passes that test. Stepping back and looking at the objects in the system, we have a test that runs against the sweeper. The sweeper thinks it's running against the user, thinks it's running against the mailer, but in reality, the test system actually looks like this. There's only a mock and a stub. There's no user mailer involved. There's no user involved. Now, there are good reasons that people do this. It enables a level of test-driven design that is not possible otherwise. If you have 10 collaborating objects in your system under test, you're going to have to set all 10 of those up as mocks and stubs, which means your test is going to be extremely painful to write. And this is valuable because it tells you the design is bad. And it can often do that in cases where you would not have realized the design was bad otherwise. This enables outside-in TDD, which means that I can TDD or implement the sweeper before the user exists, before the user mailer exists, because I'm just mocking them out anyway, so they don't need to actually be there. And it enables extremely fast tests. An isolated test is almost necessarily fast. It is very rare for an isolated test to take more than even a millisecond to execute. And even a millisecond is a lot of runtime for an isolated test. So these are all valuable things. But they come with one huge, horrible downside that is glaringly obvious, which is that in test, my sweeper runs against a mock and a stub. In production, it runs against a user and a mailer. And if I do not mock and stub those things exactly right, then the test will pass, the production system will be broken. And people see this and they say, well, obviously isolation is stupid. but they don't see those benefits. Those benefits are real, and they are very valuable. The question as to whether they're worth this downside is a different question. And that's really what this talk is about, trying to remove this downside. So that is test isolation and test doubles, mocks, and stubs. There have been attempts to fix this, to solve this problem while keeping the benefits. One of them is the idea of contract and collaboration tests. This was proposed by J.B. Rainsberger. This is basically the idea of writing even more tests to verify both ends of the interaction to make sure that you remove certain types of mistakes you could make. There have been tool approaches in the mock library in Python. There is the autospec stuff. There's autospec and create autospec. And those sort of make sure that the method you're calling at least exists on the object. In Ruby, there's a tool called rspecfire, which does a very different thing but achieves sort of the same goal. And of course, like anything in life, you can use a type system to solve this problem. If you think of every mock as a subclass of the real thing with all the implementations of the methods removed, you can see how the static type system could enforce the boundaries and make sure that they don't go out of sync with the actual collaborating objects. And the final way to solve this is to just give up and write an integration test, right? And this is what people tend to go to when they have that first reaction of, oh, there's this very obvious downside. Well, we shouldn't do isolation. Let's just write integration tests. The problem with this is that integration tests are a scam. And this is once again due to J.B. Rainsberger, the same guy who proposed contract and collaboration tests. He did a talk with this name. I highly recommend it. It's a really good talk for understanding isolation, and he really sort of breaks it down to its fundamentals. I'll give you two really quick and dirty arguments for why integration tests don't actually work at scale. The first is that the number of paths to your program goes like 2 to the n if you have n conditionals. And if you want to write integration tests for fine-grained behavior, in other words, you want to hit every side of every conditional, you have to decide which of these 2 to the n paths are actually important. And this is a very difficult thing to do. 2 to the n is a large number when n is even 500, let alone 5,000. The second problem is that suite runtime is super linear in an integration suite. And I know I've said this at PyCon before, so some of you have heard this, but every time you add a test, you're slowing the suite down because you added a test that has to run. You also added production code, and because your tests are all integrating, a lot of them are going to hit the production code you add, so all the existing tests in aggregate are going to slow down. So you add a test that the suite gets slower, you add production code, the suite also gets slower, 2 factors slowing the suite down, and I believe that you get O of n squared test suite runtime, although it's very difficult to verify that in real systems. You can't check out commit 1 and expect it to build, right? That's just unfortunately not how the world works. But anyway, you have severely superlinear numbers of paths to your program. You have superlinear test runtime. Integration tests just break down at large numbers of tests. So right now in this talk, everything is bad. There have been all of these sort of proposed solutions. None of them are convincing to me. They either solve only a small piece of the problem, or in the case of the integration test solution, it's really not a solution. It introduces other huge problems. To actually get to what I think is an actual solution, we have to switch gears entirely for a minute and talk about values. And by values, I mean things like for, or the array of the string foo. Things that are primitive values that don't have any behavior on them. If you want to test plus on integers, and let's say machine integers, and you want to do it in isolation, so you want to not interact with any other code, you don't have to do anything special, right? You just do 1 + 1, you get 2. There's no magic there. It's not going to, you're not going to do 1 + 1 and it sticks 2 in some global variable and you have to go get it. And it's not going to, import date time and start doing stuff, right? It just adds them and gives it back to you. And this is not because plus is simple, although plus is simple. It's because it has 2 important properties to get natural test isolation for free. The first of which is it's a function, right? It takes values and returns values. It doesn't do anything global or anything like that. The second is that it has no dependencies. It's self-contained. It doesn't import date time and use it to add numbers. And I think my network just crapped out. Oh, no, there it is. So let's try to rewrite that original sweeper test as an isolated test using these rules. Value in, value out, a function, and not interacting with any other dependencies in the system. So first of all, anytime you mock or stub an existing object, you are replacing a dependency. So in this case, we're mocking the user mailer, and user mailer is clearly an external dependency, so we just can't do that. We're just going to have to remove it and deal with the problem later of how do we actually make that assertion. Second, Bob is a mock here, and I want to remove that again because this is replacing an external interaction. So let's use an actual user object instead of a mock, but I don't mean like a Django model. I mean a struct, a thing that is just data. It's a value. Right? A Django model is not a value because it has complex behavior and it has this giant object graph being dragged along the floor behind it. Finally, we cannot patch user.all because, once again, it's an external dependency. We're not allowed to have those. So instead of patching user.all and then running the sweeper, I'm going to change the name of the class and say, this is now just an expired users class. I pass Bob in, the array of Bob. I should get the array of Bob out because Bob is, in fact, expired. And I would write a second test that says if I pass someone who is not expired in, I don't get them out. So I've replaced the sweeper with a simple filter class. That's all it does. And we're going to get back to how we integrate the sweeper later. The production code, of course, changes. This is the original production code you saw before, where it finds all the users and then emails each one of them. And now it's simpler. It really just finds the users. What we've done is separated the query part from the command part. We've removed the command part. But that's not even the point. The point is that we now have a naturally isolated function. We can test it in isolation. We don't have to use stubs. We don't have to use mocks. The test will be fast, and we'll get most of those benefits of isolation. At a higher level, at a sort of conceptual level in the system, what's happening is that the value is now the boundary. It used to be the case that the sweeper called user mailer, and those were the boundaries from sweeper. Now the boundaries are values. They're just pieces of data that we can reason about easily. So to get natural isolation, you need to do value in and out, meaning functions. You need to remove all of your dependencies, and then everything will be isolated for free. Now, this is not the grand solution to everything, as you might have guessed. And to get to why it's not, let's quickly talk about the various programming paradigms. I'm going to talk about 3 of the big 4 because logic programming is too weird for me to talk about. Here's a bit of procedural code. When it's feeding time, we loop over all of the walruses, and we put a cheese into each of their stomachs. Now, you can tell this is procedural for 2 reasons. First of all, there's a for loop. And whenever you see a for loop in Python, something destructive is happening. It's either destructive or it's a no-op, and hopefully you're not putting no-ops in your code. The second reason you can tell it's procedural is that we know the structure of the walrus. We don't tell the walrus to eat, because that would be OO. We reach into the walrus and manipulate it directly. So those 2 properties combined, the destructive manipulation of an object plus knowing its guts, that makes procedural code. The OO version is sort of similar. We're still destructive. We still have a for loop, but we tell the walrus to eat. And of course, the walrus then has an eat method that shoves the food into its stomach, but it's encapsulated within the walrus. And this is the difference, the big difference between OO and procedural programming. So we have right now 2 ways of solving this problem of feeding walruses. They both involve mutation. One of them combines data and code into things that we call objects. The other one keeps the data and code separate and lets the code know about the deep structure of the data. The third paradigm, putting logic programming aside, is functional programming. So in this case, we can't use a for loop. A for loop in Python is not functional. Instead, we are going to use a list comprehension to build a new set of walruses. So we're going to iterate over them and then call an eat function with the walrus and some cheese. And in this case, I'm going to use strings for the food, arrays for the stomach, and hashes for the walrus because we don't have objects. So the eat function is kind of weird. It takes the walrus and the food. It builds a new stomach that is the old stomach plus the new food. And then around that stomach, it constructs a new walrus that is the old walrus with the new stomach dropped in. This is why functional programming is not that great at modeling real world systems, physical systems. Anyway, this is the functional version because nothing is being changed, right? We're just building new values up. Nothing is being mutated. So now we have 3 paradigms. And in functional, there's no mutation, and the data and code are separate. But there's clearly something missing here, and not just because I left space for it, but because we have 2 variables, right? Does it mutate or not, and are there objects or not? And they vary independently, so we should have 4 entries. So here's what the 4th entry looks like. It, once again, is functional from a computational standpoint. It constructs new walruses. It doesn't change existing walruses, but it tells the walrus to eat the food. And that doesn't mean, hey, walrus, change yourself. It means give me what you would look like if you ate the food. So the walrus has an eat method that constructs a new walrus with whatever state the old one had. In this case, I passed a name along. And then the new stomach contains whatever the old stomach did plus the new food. So nothing is being changed, but we do still have objects. And this is the fourth entry, and I half-jokingly call this faux O because it looks like OO, but it's really functional. In any case, it does not involve mutation, but it does involve objects. So now we've talked about the good things about test doubles, the one horrible thing, what I consider failed attempts to solve the problem, values leading to natural isolation, and then this sort of faux O style of programming, which is just an extension of values everywhere. And now we can put all this stuff together and see how we can build actual systems with isolation that do things like talk to disks, because faux O can't talk to disks. It doesn't have any destructive capabilities. Going back to the original example, the sweeper, we have a user database, it's not functional. We have a mailer, it's not functional. We have an expired users class that is functional, and currently they don't talk to each other. We need to combine them into an actual system instead of just separate components. So taking the expired users class we already have, this is the second version, the functional version. Let's redefine the sweeper to use the new expired users class. So it's going to pull all the users out of the database. It's going to shove them into the expired users class to select out the expired ones. And then for each of those, it's going to send an email. It's nice, easy to understand code. If you look at this, and if you stared at this for a while and thought about what are these two classes doing, you would realize that I didn't just break this up arbitrarily. The change that was driven by the desire for an isolated test without mocks actually was a very fundamental difference in the natures of these two classes. And that difference is that expired users contains all the decisions in the system. It decides, is someone active? Has someone not paid in the last 31 days? And based on those two, is someone late? The sweeper contains no decisions, but it contains all the dependencies. It depends on expired users, and the user mailer. And this is exactly the distinction that divides what an isolated test is good at and what an integration test is good at. So what I call the functional core of a system built in this way has a lot of conditionals but very few dependencies and hopefully none. And this means that everything is tested in isolation for free. This is exactly what isolation is good at. It's good at complex cases, but it's very bad at mocking out lots of external dependencies. That becomes a mess. Around the functional core, you put an imperative shell, and the imperative shell has lots of dependencies but very few conditionals, very few paths through the system. And this is exactly what an integration test is good at. It's good at making sure lots of pieces work together correctly. It is bad at making sure that lots of fine-grained details are correct, because that's going to be a lot of test cases, and for all of them you're going to have to worry about you're going to have to worry about setting up these external dependencies. I like to visualize this as sort of a thin ring of imperative shell around lots of small functional components, most of which don't talk to each other. The imperative shell just kind of calls down into these components like expired users, one after another, to get the work done. And of course, the imperative shell also negotiates with the nasty external world of networks and disks and things that fail and are not functional in nature. So now we have a way to build programs. And for most of the bulk of those programs, we're going to get free isolated testing, because they're going to be small functional components that don't interact with each other or interact with only a few other components. And now I want to make what may seem like a very random connection to concurrency, because it turns out that this works very well in concurrent systems. The model of concurrency I have the most faith in as something approaching general purpose, not a solution for everything, but the most general, I think, is probably the actor model. And the actor model is processes with inboxes where they send each other messages. So I'm going to use the queue you see on the screen as the inbox for process 2, and I'm going to build an echo program. Process 1, I'm just going to use threads because it's easy. Process 1 is going to be a thread, and inside of that thread it will do an infinite loop, reading from standard in, and then pushing whatever gets into the queue. Process 2 is going to be started in the same way, boring thread stuff, and it is going to go into an infinite loop, reading from the queue and writing to standard out. So it's an echo program broken into two different processes, communicating via a queue, and that queue is the inbox for process 2. And this is my caricature of the actor model. It's the simplest explanation I can come up with. how does this relate to functional core, imperative shell, and to values and all of this stuff? Well, if you think about sending things between processes, every value your system has is a possible message to another process. This is not true of something like a Django model. You can't just send a Django model through a pipe to another machine and then have it come out the other end and work, right? That's not the way things are, because there's that giant mess of objects dragging on the floor behind it, and because it has connections to the database and all kinds of stateful stuff. But if you're just using structs, you can just send them to another machine. And if the boundaries between your classes are just structs, then you can switch those class boundaries to process boundaries much more easily. And this is a special case of the value is the boundary, like I mentioned earlier. Unfortunately, this is a short version of this talk, so I can't show you an actual code example from the sweeper. But you can imagine breaking it into 3 classes, a sweeper, expired users, and a mailer, where each one passes to the next one. So the sweeper pulls things out of the database, sends them to the expired users. Expired users pulls them out, decides whether they're late, and passes the late ones to the mailer, and then the mailer sends emails. Excuse me. So that's a very nice connection to concurrency that just kind of falls out of this. Now I have a more extended example, because I have built a system in this way, and I've built pieces of other systems in this way as well. It is written in Ruby. I hope you won't get mad. I'm going to... Somebody had to boo. It's a command line Twitter client. You can see it right there. If I whack the J key, it's going to scroll down through the tweets, so it's stateful like Vim would be. You can guess which editor I use. And I'm just going to give you a very quick overview of a couple small pieces of this. So excuse me. There are a lot of external resources in the system, and 2 of the nastiest ones are the keyboard and the screen. And these are negotiated by the view. So the view is basically the imperative shell. It is the boundary between those external resources and the functional core. If we look at a piece of it, this is the timeline view, the one you saw rendering those tweets. When a key comes in, it does one of many things. If you hit C, you're composing a tweet. We're not going to worry about that. If you hit J or K, you move down or up in the list. Now, in traditional OO, I would say, when J, then cursor.down, right? I would tell the cursor, move down. But that is not what's happening here. I'm telling the cursor to move down, it's giving me a new cursor, and I'm reassigning that to an instance variable. And it's a very mundane difference, but it means that the cursor can be functional, and all the state is outside in the view, in the shell. Of course, there's other stuff it can do, but we're not going to talk about any of that either. I'm concerned with down and up. So we have this view, it's talking to the cursor, which is a piece of the functional core. And the down method is going to, first of all, guard against having no tweets. If we have no tweets, then we don't have anywhere to go, right? We just return ourselves. Yes, there's a postfixed if, it's Ruby. If we've passed through that guard, then we need to decide where we're jumping to in the tweet list. So we're either going to go to the last index in the array of tweets, or we're going to go to wherever the user said he wanted to go, whichever one is less. So we don't want to go off the end of the tweets, is what this is saying. The last index is the count minus 1, unsurprisingly, and the requested index is wherever we started at, the selection index plus whatever amount the user requested to go down. Once we have that, we then just construct a new cursor, cursor.new, same old tweets, new selection. And when I say tweets.fetchIndex, I'm just pulling the indexed tweet out of the array, so it's stored as the selection. This is functional. There's no mutation going on here. It is very easily tested in isolation. You just push values in, you get values out. Now, I also I have another piece in the functional core. The other really interesting piece, I think, is the renderer. I'm not going to show you the code because, once again, I have a short slot, and this was a 45-minute talk originally. But the renderer's job, traditionally, when you think of a renderer, its job was to take the state of some system and draw it, right, on a screen. The problem with that is the screen. The screen is this nasty, stateful external thing. So that's not how my renderer works. Instead, I take basically a cursor in, and then I emit what you can think of as an array of strings. And each string is just what happens on that line of the screen. So the renderer is a pure function from a cursor to an array of strings. And this allows me to test it easily. It's about 100 lines of code. I test it by just putting a cursor in with some well-known tweets and then asserting that I get the correct text out to draw on the screen. What I don't have to do is mock the screen out or stub the screen out. I don't have to worry about that horrible stateful external dependency. All I have to worry about is values coming in and going out. The view's job then is to take that representation of the screen and send it to the screen class, which is going to draw it. And that takes like 6 or 8 lines of code. It's very little code. But if I had put it in the renderer would be very difficult to test. But by just removing that small piece of stateful code, the renderer is very easy to test. So that is my example. I apologize I couldn't show you more of the code because I don't have time. But finally, I want to make a couple of connections to other ideas in the software industry in what may seem like very different ideas that actually relate quite closely. Like, for example, the I/O monad. I just said the M word, I'm sorry. But the I/O monad is all about separating the parts of a program that do I/O from the parts that don't. And that effectively is exactly what I'm doing. I'm separating the stateful parts of my program from the functional parts. I'm not doing it in a statically verifiable way like you would in Haskell, but it's the same idea. You should also see shades of hexagonal architecture, or the ports and adapters pattern in this. The shell is really an adapter between the functional core and the nasty external world. So I'm just building adapter after adapter inside of the imperative shell to hide the external world from my functional code. And finally, I think that in a large system, you don't have one giant shell around one giant core. That would become a mess. What you have is lots of small functional cores, lots of imperative shells wrapping them, and them communicating probably via messages. And if you know the actor model, then I pretty much just described it, right? That is the actor model. Erlang is a functional language that also has processes that can send each other messages, and that is exactly what I'm describing. Erlang doesn't make the distinction quite as strongly because you can send a message from pretty much anywhere, but it is still fundamentally a very similar idea. And just as a bit of sort of summarization, I've found that writing code in this way allows very easy testing because isolation is basically free. The tests are very fast, almost necessarily, so you don't have to worry about your 100 millisecond integration test or 100 millisecond thing you call a unit test but actually isn't. There are no call boundary risks. I'm not mocking and stubbing. My Twitter client, the entire functional core is maybe 400 lines of code. It's not huge, but it's 100% tested, 0 mocks and stubs, and 100% isolated. So I did get exactly the benefits I wanted, and I got exactly none of the drawbacks that I didn't want. For certain types of concurrency, you do get easier concurrency. The Twitter client is written using the actor model. I believe there are only four processes running when it's up. But moving those boundaries around was always very easy, and moving from sequential execution to those actors was extremely easy. It was almost free. And really, that's a special case of you get higher code mobility in general. It is easier to rearrange the boundaries of a system that communicates via simple values than it is to rearrange the boundaries of a system that communicate via sequential blocking method calls that are inherently sequenced in time. So that is what that weird diagram on the bottom right meant. Now you know what all 8 of these little pictures were on the title slide. My name is Gary Bernhardt. I run Destroy All Software, which publishes screencasts. And if you're interested in this, there is a screencast on Destroy All Software called Functional Core Imperative Shell, where I go through that Twitter client in detail and show you the functional core, the imperative shell, the nice testing properties. And I even show you how it interacts with nasty things like select2 and threads, native threads, and all kinds of stuff. So thank you guys very much for coming and listening.
So I think we have time for one question. So does anybody have a question for Gary? Just approach the microphone in the middle aisle here.
One question, make it good.
A lot of pressure.
No pressure.
So you mentioned a few times the Django ORM.
Yeah.
I'm wondering how I think you called it FOO, is that right?
Yeah, FOO.
How your FOO works. So first of all, if it can, and if so, how it works with things like the Django ORM.
Yeah, it doesn't. I mean, the Django ORM is inherently extremely stateful, right? And the thing that I would do, if I were building a large system with a web framework like Django or Rails, which is usually what I'm more often thinking about, I treat the framework as an infection to put scar tissue around. Like, I want to hide my real application from it as much as possible. And Uncle Bob talks about this. He talks about the framework being the delivery mechanism, but it is not your application. And so in a large application, I would probably duplicate a lot of those model objects as just values I could pass around easily. And then they would get mapped onto the Django values, but the Django models would be very thin. They would just be for persistence. And I could make all kinds of arguments about single responsibility and stuff, but I don't think I have time. So,
right, so yes, that is all the time we have. So please thank Gary for his talk.